Welcome to Let's Calculate Something. Today we have another interesting calculus problem where we're going to use derivatives to find maxima. And so in our case here, we have a right circular cone with the same axis as a right circular cylinder, and we're going to try to find the volume of the largest volume of the cylinder that'll fit inside the cone. Okay? So we have a cone that's 12 high with a radius of 4. And we've denoted the cylinder with by the little r, little h, because we don't know the dimensions of that. We're going to try to figure that out. I've taken a cross section of this and drawn it over here. We have a few things to define that will help us with our problem. First of all, we know the height is 12, like we have over here. And then we know the radius is 4, which we had over here. And then the radius of the cylinder is r, and the little piece in between the edge of the cone and the edge of the cylinder is 4 minus r. We have two triangles that we're going to look into here. I'll kind of highlight where they are. One is here, one vertex is here, one vertex is here, and one is here. And the other one is this one and this one. Okay? So we have triangle AEB, and we have triangle DCB. And they're both similar, and that's really important for this problem because since they're similar, we know that the ratio of the heights of the two triangles and their lengths, or the sides of the triangles, those are in proportion, right? So we can immediately write an equation that will relate the h and the r of the cylinder with the known information. Then we can use this formula here, which is the volume of a cylinder, and we can solve. We can find the maximum volume by relating r and h through this equation, putting it in here, taking derivative of either r or h with respect to volume with respect to r or h, set it equal to 0, solve for the one, substitute for the other, and we have all the information we need and we've solved the problem. So let's get started. So using similar triangles, we know that 12 over 4, taking this dimension here of EB and AE, 12 over 4 over EB, I'll just write that, AE over EB equals CB, or I'm sorry, DC over CB. Okay, so AE we know is 12, and we know EB is 4. And we know DC is H, and CB is 4 minus R. How do we know it's 4 minus R? We know that this is R, and so this little piece that's left here is 4 minus R. And if you add those together, you get 4. So that is 4, right? Okay. So we know this relationship, and now we can cross multiply these and solve for h in terms of r or vice versa. So we get 12 times 4 minus r equals 4h, and that's just simply cross multiply. Now we get 48 minus 12r equals 4h. And to simplify the problem, let's just divide through immediately by 4. And this will become 12, this will become 3, this will become 1. So we know h equals 3r, 12 minus 3r equals h. So h equals 12 minus 3r. Okay? So we now have that piece of information. Now let's use that in this formula. So the volume is going to equal pi times r squared times 12 minus 3r. Okay, that's just basically substituting h in terms of r. So now we can set that equal to 0. I'm sorry, we can take the derivative of that. So before we do, we'll simplify. The volume equals pi r squared times 12 minus 3 pi r cubed. Okay? Taking the derivative, we will get derivative with respect to r equals 2 times 12 times r, so 12 pi, 24 pi r minus 9 pi r squared. Okay. Now, we can take, I'm sorry, that's not right. Yes, that's right. Okay. So now we can set that equal to 0. And since we did that, we can divide through by 3 pi. We do that, this will be 0 equals 8r minus 3r squared. Okay, so really we just divide by 3 pi because the pi can cancel because we have a 0 over here, and then the 3 will cancel because we have a 0 over here. That'll become 8 and it'll become 3. Okay. Now we can solve this, simplify it a little bit more, and it equals r times 8 minus 3r, right? It's the same thing. So solving for 0, we know r equals 0, and r equals this equaling 0, so that would be 8 divided by minus 8 divided by minus 3, which is 8/3. And we have our answer. So now we know the minimum, which would be 0, that would be the smallest cylinder we could fit. But we also know the maximum radius that would fit, and that is r over 3. And that's what we're looking for. So that is our answer for r. Now, if I take that back over here, using this height, h equals 12 minus 3r. We use that again. We know r is 8/3. H equals 12 minus 3 times 8 over 3. These 3's cancel. So h equals 12 minus 8 equals 4. And that's our answer. So we now know that the radius that we're looking for here is 8 over 3, and that equals 2 2/3, and we know that the height is 4, and that's the largest volume. That's the dimensions for the largest volume cylinder that will fit inside this cone. And if you want to find out the volume, you can simply take this height and this radius and plug it in here, and you can calculate the volume. I'll let you do that on your own, but I'll tell you what it is. The volume equals 256 over 9 times pi. And that is the maximum volume of that cylinder. Okay, so if you learned something from the video, we'd appreciate a like. And if you want to add a comment, give us some feedback, we'd love that. If you have any problems or suggestions, you can put them in the comments. We may solve them, and if we do, we make a video about it, we'll give you some credit. And then if you can subscribe to the channel, you'll see our future videos as long as you click that notification bell. Appreciate your support. We'll see you next time.